morning. Good morning. And welcome to this thematic track session 3.4 on smart grids, digitization, and electric vehicle charging. And my name is Tika Limbu. I'm a principal energy specialist working in ADB. And I'll be moderating this session. And obviously, just to, in the context, distributed energy, renewable energy, energy transition, system integration, green hydrogen, smart grid, energy storage, market, and the cyber security, etc., are very common names in the current power market, power system. And often system operators, market operators, generators, they face increasing challenges in this in the system to operate sustainably and reliably. So in this context, our session will talk about how the smart grids and digitization of energy system with the state-of-the-art information technology are being deployed to meet the increasing demand for distributed renewable energy integration, energy management, electric vehicle charging, promoting green energy, and maintaining secure power system. So we have speakers from a diverse background. We have representatives from academia and power and energy agencies from the government. We have experts from the consultants who are working in the emerging area, and they will share their innovation, successful project stories, with their presentations. And just to remind, each presenters will have 10 minutes only 10 minutes. And there is a very strict guidelines that after the 10 minutes, the control room will automatically switch off the presentation. Sorry for that. That's the instruction. And so please bear with us and be in time. And without any delay, yeah, please take your seats. Thank you. So we have a first presentation on smart grid and solar-based electric vehicles charging, case of Guwahati city in India. And it is being presented by Ms. Susmita Ajwani, please. And she is the director for Power and RE with ICF Consulting India. Susmita has over 17 years of experience in energy sector, especially in RE integration, and she leads global projects in her company in the field of renewable energy, electric mobility, green energy transition, urban planning, including policy and regulation advisories in the area. So now over to Susmita, please.
Thank you, all of you, and thank you, Tika, for introducing me. So without wasting much time, since it's 10 minutes clock, so I'm going to present about how solar EVCS is important, and it's important for the overall grid integration. And we'll present a case of a northeastern city in India. So if you see globally, India has the third largest auto market, and EV share is currently hovering around 7%, which is around 1.52 million registered EV vehicles. And the sale of EV has tremendously increased in last 1 year. It is more to do with the affordability increase. It's more to do with the incentives the government is giving. So there is a clear path that the EV adoption in India will increase many-fold and will definitely meet the target the way government has set in. So if we see EV target that India has set in, it is for 2030. So they call it EV 30 at 30. Which means 30% of new vehicle registration has to be in the electric vehicle segment. If we convert it, it comes to around 80 million vehicles that needs to be in the EV. So the amount of demand that the target has created and the slow adoption, the adoption which India has started towards this target will create a lot of demand for a sustainable EV charging system, both at the public places as well as the residential places. Now, if we see the demand for EV charging station, we use the ratio of 1 station to 20 vehicle. So around 4 million charging station by 2030 will be required. But as of February 24, we just have 12,000 EVCS operational, which is only 0.3% of the estimated demand. So the ratio currently in India hovers between one charging station to 135 vehicle in certain states, and in some states like UP, it goes as high as one charging station to 1,000 vehicles. Given this anomalies, the charging station development in India will take a quick step as we move forward, and it's visible. Most of the utilities of India across the states are taking new and wider projects around EV charging station. Now, why solar PV based EVCS and how it helps? So you can charge your station directly through a grid. You can charge it through a solar off grid plus grid combination. You can make it completely off grid with solar and battery, and you can keep solar battery plus off grid. There are many combination, but what solar based EVCS will ensure is that when we talk about EV, we talk about reducing carbon emission. But if we keep connecting to the grid and consume thermal, it is not meeting the objective in its full demand. So solar based EVCS is actually closing the full value chain by making sure the carbon emission reduces in its full goal. It will reduce the grid load. So currently, India's peak demand has reached 260 gigawatt, and in certain states, the demand goes around 80-20 gigawatt. So given this increasing demand and the variable energy which is also entering the grid system, it is important. EVCS, the kind of demand EVCS will create, it will not be a continuous load, it will be a fluctuating load. So more and more balanced off-grid mechanism come into play, will balance the grid overall. Reducing overall cost, of course, yes. If we have seen the last 1 year trajectory, if we see the last 1 year trajectory, the prices of solar module itself has gone down from USD 0.48 per kilowatt to 0.22 per kilowatt. The module price has declined by 50% last 1 year. Every year we hear that the module prices have reached its plateau, but again the prices have gone down as we see in April 2024. I think I missed that slide. In April, the prices in power exchange during solar hours touched close to 0.024 USD per kWh, which is INR 2 rupees per kWh, which is again a good showcase that solar prices have declined. There is oversupply of solar in the system. So how you utilize the solar to meet a cost-effective EVCS is an important way to look into. The biggest challenge with this mechanism are the non-sunny days. If I make a full off-grid system and we do not have a grid backup, what we do during monsoon or a peak winter season or a foggy season, so this is one challenge which battery storage can play an important role. However, the prices and of course the requirement of charging the battery storage will need to be taken care of. Now, if we look at the mechanism, how we incorporate solar PV, what is the steps that we take when we design a solar-based EVCS? First, we do the demand of EV charging, what the particular location will go for. The second step we go is what is the potential of that particular location to have a off-grid solar system which can meet the EV charging. Once the solar PV setup is done, how much can be transferred to battery storage or battery swapping, because it has to have excess solar power to charge your battery storage, and then the residual power will be taken from grid. Now, in this whole mechanism, it is important to understand, like in cities of India, there is a density issue. Not all location will have the ability to take solar power from the grid. So there are concept of solar feeders also, where you can have like off-site solar projects, where large projects you can take it through grid. However, there is an energy accounting mechanism. I'm not going into that. I think maybe our next speaker will talk about it. So if we look into the entire mechanism, we do a simulation model across this entire designing. We run quasi-dynamic simulation model where, because EV demand is not continuous, it will be based on the behavior and cycle of demand charging that the consumer is doing. So we run a quasi simulation where time period based charging is mapped, and then final integration mechanism is done. What we try to achieve is optimum engineering. What is the economics? How I reduce my cost? So in EV, the main mechanism is if somebody is adopting EV vehicle, his running cost has to be reduced, and the running cost can only be reduced if my electricity cost is reduced. So to increase the adoption more and more, how I make the economics work, it's another important aspect of designing the entire solar EVCS. Of course, the feasibility and the optimal setup of how we make grid and solar work together. In this entire value chain, when we plan a solar EVCS, because solar has limited hours of generation, it requires a behavioral change in consumers also to charge their vehicle. So if they see the value of charging their vehicle during solar hours, where they are reducing the cost maybe by 20%, 30%, they will move to charge their vehicle to the like an office setup where you have a parking, and you can charge at a lower cost. Usually a vehicle is charged once in a day. A long duration vehicle charging is more preferable. It should be a preferable choice, because fast charging deteriorates your battery life. So if solar based load charging during morning hours can be done, cost can be reduced, off grid can be promoted, and dependence on grid can be reduced. So in the entire model, only planning will not work. Behavioral change of the consumer also needs to be taken care, which can be done by slow adoption or awareness creation of the client. So now, solar-based EVCS is not very new topic. Mitsubishi has put a plant in its location in 2011. It has 96 number of panels with 175 watt solar panels each. 2 charging points, 4 charge can be charged at once. It's an off-grid location, and it has a capacity to charge level 1, level 2, as well as level 3 charging, where level 3 charging can charge Mitsubishi vehicle within 25 minutes. In Philippines only, recently, March 2024, Pasig City has started a 3 charging terminal, again on solar based. It can operate off grid as well as on net metering basis. When the vehicles are not charging, the power can be sold back to the grid, bringing profit to the unit. So this is like, no, there is an adoption, but there is a slow adoption to this part. There are many pilots have been done across globe, whether it's US, France. There are successful case studies. However, rapid adoption has not been taken, maybe because large-scale grid projects have been given priority. Now, as in India, more and more focus have been given to rooftop solars, and the ministry is trying to meet the target through rooftop solar. These projects may take shape in a bigger way. Now, in the northeastern city, it is currently in a planning process. It is need to finish the entire work. The utility there is trying to maximize off-grid solar in their EVCS EVCS planning, and what steps they have taken to achieve that. Now, if we see in this entire project, they have first taken a route rationalization. What are the perfect route where they can set up the EV charging and there will be higher demand to make it commercially operational. The most important part of the entire study is just not identifying the location with the appropriate area for parking and the rooftop availability, but also estimation of RE potential across season on 15 minutes time block basis, and how it can help the grid to reduce the load and extract more and more benefit from the solar. So a simulation model was created using open source model, and a network model was run alongside the RE potential for all the grids. And finally, around 60 EV charging locations were studied. Of that, 47% of the location could be switched to solar rooftop. Now, based on this study, they are doing tender and bringing, looking at the market response to whether developers are coming with this holistic solution of solar plus electric vehicle charging station. They are also planning to do a pilot by themselves to make it a demonstration project. In EV, the demand is not a lot. It is the variability that needs to be taken care of, and availability at the right time when the consumer needs it. So the entire process has, like, no, it may sound simple, but the grid analysis, how the pattern of charging will happen, how the battery swapping can be optimized in a location, how it can be standardized given the vehicle size are different, needs to be looked into. Now, it's a typical one case that we will demonstrate. It's a proposed location in that city where the charger and power demand, we have looked for a commercial area. It's a mall setup. 50 kilowatt DC charger at four chargers they will be required. 22 kilowatt charger, six a number will be required. Total power required is coming out to be 339 kilowatt. And solar rooftop capacity installation is around 339 kilowatt peak. This is a project which is now being moved forward for implementation. Power replacement across the life of the plant has been seen for 55%, given the variability of solar generation. Capex been seen as 275,000 USD. Payback period coming at 10 years time period. Investment will be done by utility. It is done on a cost plus basis. Right now, a return of higher nature is not being seen for this project. Finally, what we see out of the 60 location, 47 has the potential to do a rooftop solar system where solar can share the demand for it. Total 395 total 395 charging station will be installed. It will lead to around 1.5 million ton of carbon reduction. Total demand that is coming out across the city is 10 megawatt, in a fragmented way. More than 4,000 employments will be created, and a lot of private sector investment that we see coming to this project. So thank you. If there is any question, we'll be happy to answer. And I think I met the 10 minutes.
Thank you very much, Susmita, for this nice presentation. Of course, we will have questions, but not now. We wanted to have once for all after the presentation. We'll have a panel, so all the audience will have opportunity to through the question. Now, without any delay, because we have a very tight timeline, so we have next presentation. Oh yeah. So it's very interesting again. It's a electricity grid management through vehicle to grid, V2G, integration technology in India using blockchain to track or to charge with green electricity. And we have our presenter, Reena Suri. She is the Executive Director for India Smart Grid Forum. She has over 20 years of experience in energy sector. In particular, she's working on the sustainable development and clean energy transitions. Her major works are in electrification of public transport, blockchain for electricity utility, energy storage roadmap, and her another area of interest also is gender inclusive, resilient energy system. Reena will showcase the development of V2G in India and potential of B2G as new opportunities for energy management and grid stability. And she also speaks on the integration of blockchain technology to track certifying green energy in AV charging, which contributes to green energy, and very interesting. Over to Reena, please. Thank you.
Thank you so much, Mr. Tika, and a very warm welcome to all of you. And I would like to thank ADB and ISEF for giving me this opportunity to present a project that we have recently started the demonstration for. I'll be talking about as Mr. Tika has already mentioned, talking about the electricity grid management through the vehicle to grid, as well as the usage of blockchain to charge electric vehicles with green electricity, which has been a question that all the EV owners have been asking, that is really the green mobility is green is it getting charged with green electricity? So if we've seen with the rapidly changing landscape of the power sector, the integration of different new technology is imperative, and we have to bring out more digital technology and experiment with the technologies like vehicle to grid to support the grid with the transition that it is going through. And as we convene as ASIF, I'm very happy, and over the last 2 days, we've seen many multiple innovative projects that are being undertaken in different geographies. So, before I start, Sushmita has already talked about what is the EV scenario in India. We have our government has set aim to have electrify 30% of the electric fleet by 2030, and is aiming to go net zero by 2070. And with this journey actually started with the government launching a national electric mobility mission plan in India, and it further gained momentum with the faster adoption manufacturing of hybrid and electric vehicles program that was launched in 2015 and further extended in by 2019. And a lot of bids were invited to introduce more than 5,000 electric buses across different cities in India under gross cost contracting model. We have a huge number of electric buses coming in, and more than 12,000 charging infrastructure, charging stations are operational already in India. And our Ministry of Road and Transport and Highways has planned electric highways to offer clean and efficient surface transport with the Vision 2030, which is our Prime Minister's public transport seva program, which envisions 600 kilometers of electric highways going forward, and replacing over 800,000 diesel buses with electric buses, out of which 50,000 will be school buses. And further, to increase the uptake, huge concession in terms of taxes has also been offered by the government. India Smart Grid Forum, we've been working extensively, to advise the government on the EV policy requirement, standards required across, different states with different technologies. We have worked very closely with the regulatory bodies to create, separate tariff slabs for electric vehicles, and formulate the EVSE standards that are required for extensive scaling up. And we have produced significant, research and white papers to support the development and, of clean energy in India, including, working on EVSE charging business models, the impact on the grid with so much of demand coming through these new, charging stations coming up. And we'll also be working on electrification of school buses, and further with this demonstration of V2G with the cars, we will also be working on how we can utilize electric buses, for supporting the grid going forward. And we have done extensive studies to contribute to the electrification of the charging, including feasibility studies, safety hazard mitigation, which is one area which was not talked about. Everyone was talking about chicken and egg situation where vehicles should come first or charging infrastructure should come first. But to actually, understand and see what kind of mitigation will be required to have the right infrastructure in place, and have, the utility upgrade their infrastructure to be able to manage the kind of demand that will be coming in. And with the latest study, I won't go into all the details, all our reports are available online, but the latest study, as I mentioned, is demonstration of V2G and green charging of, green electrons charging the electric cars. So how does the V2G, work? So vehicle to grid integration, these technologies have been successfully demonstrated in some parts of the world. Several research labs and universities have commercial and done their pilots, and some places has also been commercially deployed in Denmark, UK, US, and Japan, which was the most recent example I could find in 2020. The most recent V2G trial that they had undertaken, enabling electric vehicles to supply approximately 1 megawatt of power back to the grid during the peak demand time. And how does it work? It, with vehicles demanding power one way, but, we do the technology upgrades and changes so that they can be plugged in to supply back the power with bidirectional charging, allowing electric vehicles, batteries, both to draw power as well as feed power back to the electric grid. And this will not only support the grid at the time of peak, will provide flexibility through the energy storage capabilities that the vehicles bring in. And the key benefits that are there for V2G are providing grid stability, increase in the RE integration in the grid, and reduction of power outages with support coming from the vehicles at the time of blackouts, and providing cost savings to both electric vehicle owners as well as grid operators. And also, it enables electric vehicle owners to provide grid back to the power back to the grid. And not only that, but also they, with the the new vehicles that are coming up with the vehicle to load technology, which will give back the power, can supply to their home to in time of outages and optimize energy usage as well, and support demand response programs, backup power that needed for businesses and factories, and also integration with the local RE sources, and improve resilience of community level grids. And how is this possible? It is through all the new advancements that are coming up, the ongoing the more improvements happening in the battery technologies, charging infrastructure, and all the grid integration systems, advanced systems that we have are making V2G more practical and more cost effective. And thousands of electric vehicles that will be connected to the grid can also aggregate as a virtual power plant, and support the grid at the in peak shaving. And as I mentioned about the school buses, they mostly stationary for around 20 hours. So they are the ideal candidate for a V2G service to increase the flexibility that that is needed in the distribution grid. So this demonstration that India Smart Grid Forum has undertaken, we are going to demonstrate two aspects around, with this project. We will be doing a demonstration of adoption of V2G technology with the inclusion of retrofitting of 4 Tata Nexon electric vehicles that will be fitted with bidirectional onboard AC/DC converters, and bidirectional AC electric vehicle charging stations will be deployed to demonstrate the vehicle to grid functionalities. And also, the second aspect I'll be also talking about in detail is a solution towards electric vehicle charging with green electrons. How do you track that? Like, Sushmita talked about so much of renewable coming in. And how do we really, make the owner of EV, give him, certify that this is really the green electrons flowing into the car. All RE is getting integrated into the grid, but very difficult to know, what's the source of origin, and, what energy is going where. So, but with this project, we will be able to certify and provide a certificate, and the owner will be able to track actually, if this is the green electrons flowing into their vehicle. So we have created a full ecosystem of different partners to be able to, not only demonstrate it, but to make it like like make it a holistic project so that it can be rolled out after the demonstration. It can be rolled out at a bigger scale. We have all our like policy makers on board. We have 4 utilities who have joined in with us with the project in Delhi: Tata Power, BS Rajdhani, Yamuna, and another utility in Kerala. And also we have support from the Regulatory Commission in Delhi, who will be one of the project will be hosted there. And our ski policy making body, who's the Central Electricity Authority, which by Government of India, they'll also be the observer and will be working with us on the required policies around that and technical specifications. And Tata Motors, who's the the biggest car manufacturers, electric car manufacturer in India, they have also joined in to support us on this project. So second part of this project, as I mentioned, is to demonstrate, how EV charging with green electricity would be achieved. Demonstration of electric charging with green electrons will be done. Issuance of green energy certificates will be doing. So how we are doing that is we are, bringing, we are giving an source of origin to the electric vehicle owner, charging operator, and he further will be giving a certificate to the person demanding green electricity for the charging of the car. So as a EV owner, you will have an option to choose green electricity versus the fossil fuel, other electricity to see how, what you're paying and how much, what you want to draw. So that flexibility we are giving with this demonstration. And going forward with so much of RE coming in, this will be, we will be able to take off and will be a great success. And also, using blockchain, it is very simple to have a smart contract in place and also authenticate the origin coming in and where are the green electrons flowing and how much is going in which direction. So that is, one demonstration we'll be doing. And lastly, I would like to, this is my last slide, so I'll like to end by, talking about the way forward that is there. We'll be, with this project, we are unlocking the full potential of V2G required and the with all the coordinated efforts of all the policymakers, the utilities and EV manufacturers and technology providers who have joined us. We also look forward to having the right standards in place by adopting, by working with the Bureau of Indian Standards, who are the standard making body in India, which is crucial for seamless integration of with the distribution grids and automation systems. Advanced planning between the power and transport sector can prevent network congestion going forward with the V2G adoption. And lastly, to conclude, with this demo, we aim to encourage the vehicle manufacturers also who are already working on the vehicle to load variants to also consider producing V2G enabled variants. And the car which will be used would be a demonstration, a sample for them to take up this technology forward and have the right policies and incentives for to encourage the EV owners to engage in V2G programs going forward. And also electric utilities in turn should also invest in the distributed energy resource management systems which are capable of integrating the vehicle to grid systems effectively. So thank you so much, and I will be happy to take more questions. I know I had limited time, so this is it from my side. Thank you so much.
Thank you very much, Rina. It's very, very interesting. I think definitely our audience will have a lot of questions already. I also have some of thought, in my brain is already coming. But let's please bear with us. We'll have a panel session, so we'll give opportunity to ask a lot of questions. So now we have, so third presentation is very, again, interesting. Cyber security in electricity transmission distribution for future. And this is being presented by Tami Reno. She is a manager for cyber risk optimization in National Renewable Energy Laboratory. She's a group manager for cyber risk optimization group at NREL. Her areas of work include building, marketing, distributed energy resource cyber security framework, which is a DERCF tool for power industries. Tami also works on applications of cyber security, capability, maturity model, C to M2. She is working with USAID on developing cybersecurity programs for developing countries. And now I think rather, I wouldn't like to spend more time. So over to Tami for your interesting presentation. Thank you.
Thank you. Hi, good morning, everybody. So my name is Tammy Reynolds, and I am with the National Renewable Energy Laboratory. So the U.S. Department of Energy has 17 national laboratories, and NREL just happened to be one of them. Our main focus is in renewables, and that's where our expertise lies. Approximately 6 years ago, our leadership decided to go ahead and start a cybersecurity research program as we launch out on an adventure, right, as we go through this energy transition. And as we do this, making sure that we are securely integrating these new devices. So energy systems across the globe are changing. So NREL is advancing those future systems and ensuring the safety, reliability, security, and resilience of those systems. NREL strives to be very forward-looking, anticipating the grid of tomorrow and the challenges it presents. Networked grid devices are also being controlled by consumers or third parties who may not fully be aware of the need for cybersecurity. Research has identified cybersecurity vulnerabilities in operational technology, components of distributed energy resource systems, such as PV inverters, EV charging stations, storage, and others. If hacked, the DER output could be compromised in a way that disrupts the stability of the local distribution system. Addressing cybersecurity through all stages of the process will be key to an effective energy transition. This includes everything from procurement to testing and validation of devices to deployment. Enabling good, robust cybersecurity practices throughout will help ensure we secure the electric grid of the future. So as a national laboratory, we have a lot of different capabilities, and throughout that 7 years that we've been trying to tackle this challenge, we've been able to build out several tools, and I'm going to go over just a few of them. I do want to preface this by saying that the team that I actually am a part of, we just did a reorg recently, and we have approximately 65 staff that are specifically focused on cybersecurity for the grid of the future, where we're dealing with everything from policy and compliance, helping with build out standards, not only for the US, but globally, doing risk assessments, and then we also have a full capability with being able to emulate and simulate an entire electric grid system. And then we have cyber range, where and full capabilities where we are able to test and validate devices based on the needs of the user or the customer. So we conduct regular cybersecurity assessment to help IT and OT staff to determine where their gaps in cybersecurity posture are. This is not just an IT problem, but an OT problem. And communication between all staff will become critical as we move toward a highly digitized, highly communicative energy system. NREL extended the scope of its existing risk assessment tools to include the National Institute of Standards and Technology Risk Management Framework, or 800-37, for those of you that are like your 800 series list of controls. This is going to address the challenges faced by the energy managers when complying with NIST RMF for DER systems. The NIST RMF is a cyclical process designed to incorporate principles of security and risk management into an organization's system policies and procedures. As an additional tool, NREL's DER Risk Manager is independent of the DERSIF existing self-assessment tool and allows users to focus on the RMF process. So I'm actually going to back up. So the distributed energy resource cybersecurity framework is our initial tool that we built as a foundational assessment tool and is based on several industry standard frameworks, including the C2M2 or Cybersecurity Capability Maturity Model. That particular framework was developed by the US Department of Energy in conjunction with Carnegie Mellon. And we integrated that into this assessment tool, but it also relies heavily on IEEE standards as well as IEC and NIST. Developed through the USAID NREL partnership, the Resilient Energy Platform provides expertly curated resources, training materials, tools, and technical assistance to enhance power sector resilience. The platform enables decision makers to assess power sector vulnerabilities, identify resilient solutions, and make informed decisions to enhance power sector resilience at all scales. As an example, we have partnered with NESCO and are supporting efforts in Bangladesh. We have done this through supporting the Smart Distribution System Implementation Project. And so we've partnered with USAID, NREL, and the Badge. Project hosted a training at NESCO's headquarters in February of 2024, which included modules on cybersecurity principles for power grids, cyber risk assessments, regulatory frameworks, and best practices and strategies. At this workshop, we introduced the assessment tool that I just went over a few minutes ago. And for those of you that love acronyms, we call it the DERSIF, which is not a great acronym, but because it's so bad, we hope that it actually stays with you. So the Power Grid Company of Bangladesh and the National Transmission Network Owner Operator also was a partner in this, and we supported the PGCB with developing and refining its cybersecurity policies to align with best practices, met in person to discuss cybersecurity needs, and using those results from the C2M2 and DERSIF assessment, we're helping to identify and address most of those critical cybersecurity needs. We developed the power sector cybersecurity building blocks in partnership with the LAC region within USAID, which is the Latin America and Caribbean region. These are publicly available. We held a series of webinars on various topics within the building blocks that address key topics within cyber energy space. We provided technical assistance by supporting utilities with customized road mapping and training based on results from the DERSIF tool. And in conclusion, the human aspect to cybersecurity is the most challenging, right? So we need proper training. We need to make sure that we're training our staff properly and getting them up to speed as we start integrating these new technologies onto the system and we start getting our systems to be more smart, if you will. Cybersecurity is not just an IT problem, but it's an OT problem. And we need to be communicating that across, and we need to bridge the gap between the two the two systems and all of the staff so that they start communicating and so that we can do this effectively. And lastly, cybersecurity should not be an afterthought. We need to be planning ahead and making sure that we are integrating cybersecurity in all of our planning and action from the beginning. Therefore, it will ensure that we have a more secure and resilient future. Thank you.
Yeah, thank you very much, Tommy. This is very, very interesting. It should not be like a firefighting. Once you have the outage, then you start, working. We should have a plan. I don't know how much is our investment in this cybersecurity versus we need to do. I think we have a lot of questions, but please bear with us. We will have time for her to answer. So now, next slide. So we have interesting presentation on demand response, integrated smart grids for enhanced renewable energy integration for peak demand management. It will be presented by Udana Ratnayake. He is a sustainable specialist having 13 years of experience in public and private sector. He is an electrical engineer by qualification and worked extensively in the areas of renewable energy, demand side management, and has also worked as a assistant director for public utilities regulatory commission in Sri Lanka. But unfortunately, because of logistics, he couldn't come to Manila physically. So he has provided his recorded presentation, and we will have, I think, unfortunately, we don't have a face-to-face conversation either. But his presentation basically on the demand response pilot projects with the smart grids, enhanced renewables, energy system. The project was integrated with digitized platform for demand control and optimal use of energy storage, addressing the challenges associated with rooftop solar and peaking demand in distribution network. So could you please
A
control
very
room?
good morning to all of you. First of all, I would like to thank the organizers to accommodating my presentation as a recorded presentation, as I'm unable to be there in person due to unforeseen circumstances. My topic for the day is demand response integrated smart grids for enhanced renewable energy integration and peak demand management in distribution networks. Before I get into the specifics about my topic, let me give you a brief introduction to Sri Lanka's power sector. We consume around 15 terawatt hours of electricity every year, and our installed capacity is about 5,000 megawatts. We have an ambitious target of generating at least 70% of our electricity using renewable energy sources by 2030. So we got to add about 500 megawatts of solar and 150 megawatts of wind every year, which would require 1.4 billion USD worth of investments into the power sector. So as you can see, our focus has been mainly on generation and transmission or storage, but we haven't really put much focus on the demand side. What sort of a role demand side could play in helping us achieve these targets? So that's where demand response comes into play. Demand response is all about having flexible demand, which will definitely support your renewable energy targets, because as you add more and more renewables into the grid, it becomes harder for the utilities to control generation. So obviously, they would prefer to have more control over demand. USAID Sri Lanka Energy Program is a 5-year program funded by United States Agency for International Development. We work with Sri Lanka's power sector stakeholders to make the power sector technically, financially, and economically sustainable. So we operate under 4 objectives. Activities related to demand response come under our 3rd objective, which is to improve demand side management, but they complement our other 3 objectives to increase deployment of renewable energy and promote advanced energy technologies, and also improve cost reflectivity of tariff. To give you a better understanding about demand flexibility or demand response, It's all about changing your demand as per the needs of the utility or the grid. You can do it in different ways. Either you can limit your demand, or you can shift your electricity demand to a different time zone, or you can even switch to a different energy source so that you don't strain the grid when you use a different alternate energy source. When it comes to implementation of demand response programs, those can be categorized under different aspects. So if you look at how they are controlled, they can be either decentralized or centralized. And the incentives that you need to provide the consumers to enroll in a demand response program could be either financial or it could be more qualitative. And also these programs could be pre-scheduled or they could be real time as well. You must be thinking what the perfect strategy should be to promote or implement demand response. If you're an engineer, you might be thinking of different technologies that you can incorporate. If you're an entrepreneur, you must be thinking about different business models that can make use of demand response to increase your profitability. Or if you're working for the government, you must be thinking about how you could catalyze demand response through policies and regulations. So all these aspects are important. That's why we need to have a holistic approach, bringing different stakeholders together, like policymakers, regulators, utilities, consumers, and also technology service providers, to make sure that we can implement successful demand response programs. We have implemented several pilot projects to see the effectiveness of demand response in solving some of the challenges we face in the power sector. In distribution networks, with higher addition of rooftop solar, we are facing voltage fluctuations. So when the solar generation goes up and if the consumption is low, then the voltage goes up and the solar systems tend to switch off. In collaboration with University of Moratuwa, we implemented a pilot project to see how we could solve this issue through demand response. So what we have done here is we have created few flexible loads to operate when the solar generation is high. Now, if I bring an example from a residential setting, you might have a washing machine and you may usually use it during night time because that's when you are at home. But if you could program this washing machine to operate when the solar generation is high, then the system can increase self-consumption and make sure less generation is exported to the grid. So that's the main principle behind this pilot. And we also make use of storage within the consumer's facility and also in the utility to increase charging when solar is high, and also the discharging will occur when the solar is low. So with this, we reduce what's exported to the grid, or we sort of create an artificial consumption either within the consumer's facility or at the utility end to make sure the voltage is within the range. We are also working on a pilot to see how demand response can be utilized to reduce peak demand. Now in our country, the peak demand occurs during night time, somewhere around 7 to 7:30 p.m. So what we have done here is we have created the platform that can be used by consumers to schedule their consumption. They can schedule their appliances to work during off-peak periods. And this is inbuilt with a learning platform that will initially analyze the consumer's demand pattern, and then whatever the changes they make can be measured and verified. So with that data, we will be in a position to incentivize consumers. We are also working on a demand response pilot project with Ceylon Electricity Board, which is to defer infrastructure upgrades. So some areas are congested, the grid is congested. So even though the peak is not coinciding with the national peak, when it comes to that specific area, the demand is high during certain times of the day. It could be maybe for 30 minutes. But because of the 30 minutes, you are required to upgrade your infrastructure. So what we are doing here is we have analyzed consumer consumption and identified loads that can be reduced or shifted to other time zones. So we are working with these consumers to come up with an incentive scheme so that they can work with the utility to shift or reduce the demand. By implementing these pilot projects, we have gained some useful insights. Consumer engagement is key because you rely on consumers to change the demand to implement demand response. You need to make sure that you aware the consumers about demand response and how it works. Technology access is another area that you need to work on. Consumers as well as utilities or any other third party involved in implementation will have to have access to proper technology. Regulatory support is also important even from the pilot stage, because the whole purpose of doing a pilot is with the hope to implement it at a national scale. So to do that, you need to make sure the right regulatory framework is in place, and getting the regulators involved will make the process much easier. Since these projects are implemented with the support of many stakeholders, including utilities, regulators, technology providers, consumers, you got to make sure you get all these parties involved right from the start. So in case if they have any queries or if they have any doubts, those can be clarified then and there and move forward smoothly. So always start with scalability and replicability in mind. So it could be a very interesting technology pilot, but if it cannot be replicated or if it's not scalable, the time and money that you spend on a pilot may be in vain. So always start with replicability and scalability in mind. Thank you very much for listening to my presentation. I sincerely wish I was there in person to answer your questions if any. I hope that you'll have a very insightful session. Hopefully we'll meet at ASF 2025. Thank you.
Yep. Thank you.
Very
Bye.
good morning to all of you. First of all, I would like to
Oh, okay. Sorry, it's a IT again. So, thank you very much. So now we have slide, please. It is control. Can you upload the slide? Five number slides. Where is it? So this is an energy efficiency through digitization. A work in the municipal energy markets affects impacts policy recommendation and paving way forward. This was originally supposed to be presented by Professor Gul Muhammad Khan, but he was replaced with Dr. Naveed Ahmed. He is here. So Dr. Naveed has 12 years of experience. He's a director, Building Energy Research Center in University of Engineering and Technology, Peshawar. He is a Fulbright alumni with master's and PhD and a postdoctorate in energy management, measurement on energy efficiency, smart buildings. He is currently leading a project for transformation of construction sector in Pakistan, a pathway towards clean, green, and sustainable buildings. So, Dr. Naveen, he will talk about the transformative projects, which was rolled out in 9 municipalities in Pakistan. Over to you.
Okay. Hello, ladies and gentlemen. Thank you very much for letting me present this work. As you know, I will be filling shoes for someone else, but I mean, it's a kind of a project that is close to my heart. We work together on it. We are working in the same center. So I know a lot about this project, and we'll be having a really interesting discussion. Next slide, please. Oh, okay, okay. Okay, thank you. So yes, so municipalities in Pakistan pretty much does the basic functions that every municipality in any other country does. It provides water for drinking, controls and maintain the street lights and traffic lights, have the vehicles for waste collection, and maintain their own buildings as well. Like any other municipalities in the world, our municipalities are at the receiving end of the public criticism. So, I mean, they draw little funds and lots of criticism from public sector, and especially in underdeveloping countries, municipalities find it really difficult to provide these basic services to the people or public. So we did this project with the municipalities. It was funded by the GIZ Pakistan, and the purpose was to digitize them, but actually to in the form of digitization to actually empower them, to give them this feeling of importance to them, because most of them are overstaffed and they don't get much public funding. Also, I mean, they don't have this feeling of how important their work is. So, I mean, by going to these municipalities, we actually were acknowledging the important work that they're doing in terms of, especially, like, I mean, providing the clean drinking water. All of us know if there is any issue with the drinking water, if there is any bacteria, virus, or E. coli, it can play havoc with the health of the population. So what we did was that we tried to digitize the services provided by these municipalities in different municipalities. So we actually digitized, we provided the energy management systems to these municipalities, so that one, they can see in real time how the quality of the delivery of their services in terms of their water quality, in terms of the operation of the traffic lights, in terms of the energy consumption of their different systems. So no, I mean, digitizing by connecting them to the sensors and Internet of Things, and they know they are receiving this real-time data, and they have a dashboard on which they can see the energy consumption and the other basic provision of services. Like one of the system that helps digitize the process of providing the clean drinking water through the pumping stations. And we have this, one good point about this project is that we have our own homegrown solutions. So we developed this device, which is called AquaCure. The purpose of this device is to check the quality of the water before providing it to the public, which is very good because it provides real-time measurement of the quality of the water, and if there is any issue with the water, then the corrective action is highlighted or flagged, or I mean the water system, the provision of the water should be stopped at that time if there is any issue with the water quality. So, I mean, it controls the energy control and measures the energy consumption of these water pumping stations as well. As you see, before we had this live dashboard, there were the pumps that were there were not energy efficient. Lots of them has this voltage and the current unbalanced method. If they are engineers, they will understand that it can, if we have a properly balanced current and voltage going into the motor, it can save a lot of energy. So, I mean, this is the kind of, we have lots of municipalities, and we can see that the results were really good. They saw that they were saving energy, lots of watts of electricity. Yeah, this also shows the kind of units of electricity we are saving with different municipalities. So, I mean, kind of the carbon credit that can be saved by these municipalities, and that can be traded by them in future to earn more revenue. It also sees that the return on investment or the payback period for all these these instruments that have been installed in are very good. They are below 1 year. So it's a very good and a compelling case for other municipalities in the world to adopt these instruments and these control technologies. Yeah, it also discusses the savings. So, I mean, we have these VFDs installed on the tube well pumping stations. So the pumping stations in these municipalities are now totally controlled from the dashboard. So anyone sitting in their office can turn them on and off. They can also monitor if the energy consumption of the motor is high or low. They can also monitor if their pump is performing well, if it needs any maintenance. So we have incorporated the predictive maintenance into this system as well. Yeah. So, I mean, while incorporating these systems into the municipalities of Pakistan, we faced lots of hurdles, especially the behavioral change. It was kind of difficult to convince people that these tools are actually there to help you rather than taking away your jobs. And this is a common theme that is revolving around Internet of Things and AI and machine learning, is that people think that it is going to take their jobs. But we kind of improved the higher management as well as the staff, that it is actually going to upgrade your skills actually. And you will be a better employee. Your employability will improve if you work with these kind of systems. Yeah, the major challenge now is that we have installed them in few municipalities. The challenge is how to sustain these systems in these municipalities. Lots of trainings are required. Lots of convincing is also required for the staff members to keep on running this system. And then how to upscale it, how to provide it across Pakistan to the entire country. Okay, that's it. I thought the clock was running too fast. Are there any credits for finishing it early? Yeah. Thank you very much. Thank you.
So, thank you, Dr. Navid, for your timely presentation. Of course, you'll have some bonus, so you can answer more questions later. Okay. So, the last but not the least, we have a special request to our distinguished guest from Bangladesh, Miss Munira Sultana. She is a chairperson of Sustainable and Renewable Energy Development Authority, SREDA of Bangladesh. And we have requested her to give a perspective of Bangladesh on various aspects, in particular policy directives on RE development and energy transition, current power system status, smart grid, digitization of distribution network, EV charging system, and investment requirement in Bangladesh. And Ms. Munira is a Bangladesh civil servant. She is in the civil service from 1993 in different responsibilities in the ministries, in the direct departments, etc., etc. And she is currently a chairperson in the SREDA. I would request Ms. Munira to make her keynote speech coming to the dais and here and make a presentation, and maybe shorter would be appreciated. Thank you.
Thank you, Mr. Tikalimbu, distinguished guests, experts, academia, ladies and gentlemen. Earlier, Mr. Tika just allowed me 2 minutes for say something. So I told him that if I give the presentation, 2 minutes is not sufficient. So I can just give a scenario of Bangladesh, respective the smart grids, digitalization, electric vehicle chargings, and other subjects about the energy situation in Bangladesh. As you know that Bangladesh is a small delta country with big population. So it is very much um, crisis moment about our energy situation or power generation also. Every day, Bangladesh needs 14,000 megawatt electricity. But every day we are facing some shortage of electricity because of so many reasons. There is a primary electricity shortage is one of the main reason, and other thing also remaining. Bangladesh is still a growing country, and its growing rate is about 6% every year, and energy demand is side by side also growing the same pace. So the government has achieved significant improvements in human development indicators, including 100% electrification in the year 2022. But 100% electrification is ensured, but electric supply is not ensured 100%. Because of that reason I already mentioned. And Bangladesh is expecting to graduate from least development country status in 2026. However, the major challenge in this development is the threats from climate change and environment degradation that may reverse development gains, deteriorate livelihoods, trigger displacement, and worsen poverty also. Though Bangladesh is a less carbon emitter country, but we are still the climate vulnerable country and climate victim country also. To protect our climate and environment, we need to focus on energy production and consumption in a sustainable way, as these activities are responsible for almost 3/4 of the world's greenhouse gas emissions. As energy cuts across all aspects of development is essential to inclusive socio-economic development and gender equality, an economy-wise just energy transition is highly required. Our policy directives for RE development and energy transition as to ensure low carbon energy transition, Bangladesh government has set firm targets to have 40% of energy from renewable sources by 2041. It was announced by our Honorable Prime Minister during the COP26. Moving forward to COP28, Bangladesh has acknowledged to triple its renewable energy capacity and double the energy efficiency by 2030. In addition, our Honorable Prime Minister as well as the government just try to escalate the renewable energy 30% by 2030, and we just convert our 1,200,000 solar diesel-driven irrigation pump to solar irrigation pump by 2030. It is an ambitious plan, but we are trying heart and soul to achieve it. To support these renewable energy initiatives, the government has formulated relevant policy also. And ADB already estimated this SIP conversion in Bangladesh, it needs 6 billion US dollar, about 1,200,000 diesel-driven pump to convert into the SIP. So it's need very big investment also for Bangladesh. In our Mujib Climate Prosperity Plan, Decade 2030, where it is mentioned that the share of renewable energy will be increased by 30% by 2030, and 40% by 2041. If we increase our generation or renewable energy or any other conventional energy, the grid stability and grid resilience modernization is very important for us. So the perspective plan for Bangladesh 2021 to 2041, economic growth in sustainable way and the integrated energy power master plan IPMP 2023 also developed with to fulfill this target, that is 40% clean energy by 2041. Current power sector status in Bangladesh is the present total installation generation capacity of Bangladesh is 30 gigawatt against the peak demand of 16 gigawatt. In line with economic growth, the electricity demand is growing at rate of 6% above every year. Already I mentioned it. To meet this growing demand, the government planning to have 40 gigawatt of generation capacity by 2030. At present, the renewable energy generation capacity is around 1,360 megawatt with solar 80%, hydro 70%, and wind is 2.4%, and biogas 0.1%. So this picture is showing that renewable energy is very little or very low in Bangladesh. All time we say that Bangladesh is a small country, so renewable energy needs more land. That is the one very big problem, that scarcity of land is not very helpful to renewable energy generation for Bangladesh. About smart grid for grid integration of renewable energy in Bangladesh, we are working for grid strengthening with climate resilience features and digitalization. We are focusing on capacity expansion planning. In this regard, we are focusing optimal generation planning with flexibility analysis, dispatch analysis, operating reserve, and others. Transmission planning with transmission grid modernization, capacity expansion, software-based scheduling, distribution network planning, and demand response. On load tap changer, reactive power, control storage, static synchronized compensator, and others. We are also reviewing the policy framework of renewable energy grid integration, focusing the grid code requirement, power market development, policy support, and human resource development also. Now, come to the digitalization of distribution network. The 6 distribution entities are working in power sector of Bangladesh. And these distribution networks such as GIS mapping, SCADA integration, data center development, these entities have implemented a smart metering system integrating mobile financial services, multiple applications, and so on. All these distribution utilizers are moving toward advanced distribution management systems also in recent future with climate resilience features. Now come to the EV charging system. This is very new concept for Bangladesh. Already 16 EV charging stations are got the approval of government, and 6 are operating. 4 million battery-driven rickshaw, is now running in Bangladesh, but it is not got the status as electric vehicle, but battery-driven vehicle it is. Apart from this, the automobile electric vehicle is very few which are running in Bangladesh, but we are prepared for electric vehicle charging station, but the automobile is not just imported or constructed in our country as our own. For supporting the electric vehicle charging station, we developed a guideline named Electric Vehicle Registration Guideline in 2020 and Electric Vehicle Charging Guideline in 2022. A number of electric vehicle charging stations are constructed in different urban centers as piloting base, already I mentioned. So all those things, we need a very handsome investment to increase the power sector development for the power sector. And it required 30 billion from private sector or the development partner. ATB can help us as well as any other interested development partner can work with us. And utility scale solar of 15,000 megawatt, rooftop solar 16,000 megawatt, and wind 6,000 megawatt. It is estimated generation of RE. With this note, already my time is over, and thank you very much giving me the time, and thank you very much ADB and organizers to giving me the opportunity to say something before you.
Thank you very much for providing with the summary of status of power system and initiatives. Now we have a session, last session, which is a panel session. So I'll be requesting all our speaker to be in the dais. There is no any, it can be random, so you could take any seats as you wish. And obviously, Susmita Ajwani, Rina Shuri, Tami Reno, Udanta is not here, and Dr. Naveed, and Miss Munira. And we also have another distinguished speaker today, who happens to be with us. And I have requested him to be a panelist as well. He is Mohammad Zakiul Islam. He's a managing director of Northern Electricity Supply Company Limited, NESCO, of Bangladesh. Mr. Islam, I think you have, I don't know where you want to sit. It's up to you. So, thank you. Now, because we have, we definitely would expect a lot of questions, and we would request one by one, if you could raise your hand and intend that what is your question, then I could obviously request to our speaker. So each speaker will have one question because we are running out of time, already late by 10 minutes. Any questions to first? I think let's take the, I have many questions, but my priority is less priority than the audience priority. So if you have any questions, if you have any clarification that to be sought with Susmita Azwani and her beautiful presentation on Guwahati city's pilot project, which was successfully rolled out and which is a very success example. If you have any questions, please. Oh, two. So who is it? Okay, Miss Dr. Chapagai, I think, yeah. So please introduce yourself and be short in your question. Thank you.
Thank you very much. Very nice, wonderful presentation. I'm Narayan from Nepal, currently with GIZ. So my question to Susmita regarding the solar-powered EV charging stations. What was the cost comparison between the grid connected and off-grid? Because the battery storage, basically you if you would like to charge in the evening, that you need the storage during the daytime, maybe you are somewhere else. So what is the cost aspect of that one? How to make it like theoretically everything is wonderful, but how to make it practical so that it could compete with the grid parity. So that's my question, please.
Okay, thanks.
Not cost effective, then it is very hard to absorb. So if we see Assam's electric tariff for vehicles, so when it comes to landed tariff, after adding all the cost of utility and all, for EV charging, it comes close to 8.5 rupees per kWh to 9 rupees per kWh. But when we do a rooftop with the electric vehicle, however, it needs currently grid support also. The landed tariff comes like only solar comes around 5 rupees per kWh. When blended with your grid tariff, it reduces the cost, grid cost tariff by 1 rupees per kWh. So there is a reduction when we adopt solar. So if it is standalone one case I'm talking about, when it is taken in a wider scale, when the cost economics start working along, this cost optimization can be achieved at a larger scale.
Great, thank you. So solar is cheaper. That's great.
Okay.
Okay, thank you. So I have so many questions. Dollar, okay. Please introduce yourself and be brief in your question. Thank you. So many questions.
Thank you. My name is Daler. I come from Tajikistan. My question would be maybe to Sushmita and Rina. And our country is neighboring with China, and the number of electric vehicles and the charging station has been increasing really very rapidly. The government is providing incentive to import electric vehicles and buses. And my question is, given that the cars are being charged during the evening times, it brings more kind of burden during the peak time. And it brings burden to distribution grid and as well as to generation facilities, especially during the winter time. What kind of solution do you see in this case? Thank you.
So again, this is the similar problem that we are facing in India also. Most of the charging happens during night hour because the car comes and park there during that hour. That's why I focused with the solar integration to the grid. Behavioral change is also required. Once the EV owner gets understands there is a cost reduction during solar hour generation, and they during morning hour charging, they will automatically shift to the morning hour generation. So that kind of time of day tariff you need to introduce. I'm not sure, like in Kazakhstan, if I have heard the country names correct, it's Kazakhstan, right, sir? Tajikistan, yeah. So if you introduce the time of day tariff where we make the nighttime peak tariff more higher, and during daytime more amiable, we can shift the demand towards the morning hour. It will help you balance the grid also. Plus, if we introduce the solar plus grid during morning hours, there is a definite reduction that we can see. With battery may not be economic, but with solar and grid, rooftop solar and grid, so maybe then the EV owners automatically can shift. If Reena, you want to add something to this?
So Reena, you have any time of day tariff?
And
definitely.
Kazakhstan has great potential for solar, so definitely it should be tried.
Yeah, thank you, Sushmita. And just to add to that, they with the technology upgrades, we having the right policies and incentives will definitely help change the behavioral pattern of EV owners to charge. Of course, technology, batteries, key to store renewable and provide power back at the time when it is not available. But Sushmita mentioned about time of day. So India already has a time of day tariff for its industrial and commercial sector, but we are government has already announced the same for the going forward for the residential sector. It will be mandatory in the near future. And also, India Smart Grid Forum, we have done a pilot around time of use tariff, where every 15-minute block there'll be a incentive or a penalty. So that kind of scheduling we had done with this pilot, and there was huge saving of for the energy consumer that were that as a like outcome that has come out of that. So definitely, these kind of different policies will help. And I talked about vehicle to grid. So that is also one technology we are experimenting or demonstrating to primarily support the grid at the time of peak, so that when the consumer is incentivized to give power back at a time when it is peak, they will change their pattern of charging. So these are the different technologies as well as policies that are required to have support the grid at the peak that they are facing.
Thank you. So, okay, gentlemen, you have to introduce yourself and please be brief on your question.
Thank you so much for the opportunity. Thank you so much again for your futuristic and very insightful presentations. So my first question is the first presenter. So when you're talking about the future
Your
of EV.
introduction, I think
Yeah,
I know that you are from...
I'm Nilantha from Sri Lanka. I'm working for the regulator. So I'm asking this question in terms of the regulator's perspectives. So when it comes to the EV, so what about the language are we going to talk about? Because there are national standards as well as international standards. So as of my knowledge, there are 32 different standards for EV charging only, IEC standards. So when it comes to the maybe the cyber security or maybe any other futuristic information-based controlling, I think the standard has to be followed, especially for the regulating purposes as well. So what standards that you are following, or are there any strategic requirement in terms of in India when it's promoting this kind of E2V and G2V and vehicle to charging and the grid to charging, communication between protocol? There are so much of protocols are involving. Some are ISO standards, some are IEC standards. So which standards that you are following in India, and is it something where we can use? Is this protocol can be used across the world? That's my question.
Maybe Rina or whoever. One of the two. Okay.
Yeah, I think there are standards being defined by NITI Aayog in Government of India, where you have like charger levels that you can use to install in a particular charging station. But I will let the expert here from ISDF to answer this.
Yeah.
Oh, gentleman here. So
the president ISDF,
yeah,
I mean,
okay.
he works primarily on standards, and he has extensive knowledge
please,
around that. So maybe he can.
It's an honor to have you.
Electric vehicle charging standard development started with Japan. So the Shadamo standards came in. So later IEC adopted different standards, which is basically CCS, we call it combined charging system. CCS2 is from 2018 onwards, we use CCS2. So most of the countries where we use the same 50 hertz, the European electricity system, like in India and most of the Asian countries, we have 50 hertz system. We adopt IEC standards for everything in electricity, including EV charging. So in India, Bureau of Indian Standards in 2017 onwards, we are working towards adopting national IEC standards and other standards for EV charging in India. So we have some 11, 12 different standards for different. It's a big ecosystem. Those who don't understand will not understand. So part 1 was issued in 2018. It called IS Indian Standard IS 17017 part 1 we issued in 2018. There are some 12 standards after that, but communication between the car, the electric vehicle control center and the charger control center, that is ISO 15118. So the 6 parts are there which is adopted. But the good part is that in North America, China, they use GBT standard, which is entirely different. And Tesla, they started with their own proprietary standard called Tesla Supercharger. So these 4 different systems were coexisting. But the good news is that now everything is moving to NACS, North American Charging Standard. This was by opening up Tesla's supercharger.
Thank you. I think it's too technical. I think maybe we need to have an offline discussion and have a communication. So we can take 2 more questions because I was already given red card. So they are saying like stop. So any questions from audience, please? No questions? Okay. Then we have Mr. Islam here. Obviously, because we couldn't give him a slot for a speech, but I would request Mr. Islam that like he has implemented GIS-based smart distribution system for customer service management, which is very, very effective, efficient, and it's a novel system. So Mr. Islam, could you please highlight how the system developed in NESCO, in technology, in automation, to automate customer service, and what is it, giving to the customer? So just 2 minutes, please.
It's okay, no problem. Thank you so much to Mr. Tika for inviting me here. Actually, I would be very brief, to the point. Thanks to ADB for supporting a project, financing a project in 2020, which we started implementing in 2021. It was basically geographical information system. Since I come from an engineering and business background, we wanted to do something for the asset performance management. So whatever the assets I have, I would like to geographically plot them so that I can monitor their maintenance and supervision and everything. This was the first part. Then we implemented from a government funding is the smart metering. So we ensure transparent financial management system so that real-time reconciliation of financial payment can be done with the bank and my consumers so that there is no complaint on meter reading and bill payments issues like that. Then we decided to integrate this GIS and a smart metering system so that financial payment can be done, asset performance can be done, and accordingly what we do is that geographical location will help me to identify demand, load balancing, and as well as payment system accordingly, better fault management, better complaint management, customer satisfaction. What we did actually, we introduced substation automation system in, it may be a bit technical, so I'm trying to keep it in a simple version. We connected all our CT, PTs, and all the protection system in the substations. We connected our transformers through a smart metering system, and rest was actually OPGW. Then what we did, we introduced mobile applications with the help of ADB, and there is US company NRECA. They give us the software. So with this physical infrastructure and software connectivity, what we did, we introduced real-time complaint management system. So there was a digital map from GIS, which helped us to understand when there is a complaint, to locate the complaint, where exactly it is. Then we used to assign our team based on the complaint and the meter number and the customer phone number to locate physically. That helped us to increase the opportunity, reduce the opportunity cost. So because if there is a power failure, I am paying it to my main generating company, whereas I cannot sell it. So that business point was very important for me. So to reduce that cost, we introduced this real-time online customer management system. So that's how, with the help of ADB, with the help of NRACA, introducing GIS and the smart meter system, there was a real-time complaint management system. And simultaneously, what we also did, when the transformers, there was a phase balancing issue, we also predicted the demand charges, how much is the demand at location, and also we indicated the fault-prone areas, which transformer, which area, for what are the, you understand the Bangladesh is we operate in very remote place. So there are rainy season, there are faults, thunders, and also there is a tree falling on the lines because not all lines are underground. So that's where initially it took us time for walking all the way to the track to identify the fault. So with this applications, actually, we could locate the geographical location and immediately send our technician team to identify the fault and recover it eventually. So it helped us in one sense, the financial payment was more transparent, real time, and on other way around, complaint management, customer satisfaction was much higher, much better. We are also in the process of improving further, thanks to ADB, because they have given us one more project for implementation of cybersecurity, which I wanted to highlight, but maybe later part of the somewhere else. Cybersecurity, a smart metering system, and also advanced management system that will help NESCO to get into a more advanced distribution management system. Thank you so much.
Thank you very much, Mr. Islam. I think this is very good. So I guess we don't have further question, but because we have like a distinguished panelist, one question to Ms. Tami, because this cyber security is, I think it's coming up very like challenging, but like in like other aspect, like we do this like audit, cyber security audit, cyber security audit of the system, because it's so much integrated, which are external, beyond the control of the system operator, because there are so many players interconnected. So is there such protocol to do the cyber security audit of a system operation or of system? Any regional or state or any particular utility? Just whatever you have. Yes, no?
Sure, yeah. So thanks for the question. So the question, let me just make sure that I understand that you're asking about an audit
Yeah.
for the system. And so that's exactly what the DERSIF tool, that horrible acronym that I mentioned, right? So the Distributed Energy Resource Cybersecurity Framework is an assessment. It does not mean that you have to currently have DERs on your system, but you could be considering, right? So this assessment tool is for anyone to use. It's free. You can go out to the website and literally create a user account and start using it. Or you can contact us and we can help you walk through that process where you can then conduct an assessment where whoever is managing the OT systems and the IT systems can get together. We bring them together and we start having the discussion and going through the list of controls or protocols, if you will, to decide what you have and what you don't have, right? More importantly, what you don't have, so that we can start making plans to go ahead and get things in place so that you can bring your maturity level up so that you can start securing your system even more efficiently. And so that you, as you bring in those new technologies, your system is already secured, right? So like I said before, like, so that it's not an afterthought. It's never too early to start doing good and practicing good cybersecurity, and it's never too late, right?
Thank you. Thank you so much. I think
Yeah.
this should be under the regulation sometime in the time, in
Yeah.
the future, so that the utilities must have this kind of test, tested. So I think we are almost running out of time. I just one quick question for Dr. Naveed, because he made a presentation, nice presentation, 30% energy efficiency, like energy saving, which is great. But in the last slide, what he has presented is, despite this all, how to sustain, how to ensure managers to equip, and how to upscale. This is a very big challenge, and we often run out of fund. So have you considered like ESCO model, where the energy service provider, the private developer would come in and utilize the technology and share the savings out of the energy efficiency and whatever is achieved? Is there such things that happening in Pakistan, so that it could be sustained, it could be scaled up? Because there are not only 9 municipalities, there could be hundreds in Pakistan. So just little bit thought.
Yeah, thank you very much. That's a very good point raised, actually. So, with one of the development authority, we are working on this model. And I mean, it's slightly different. What they want is, because their bill, their energy or electricity bill is now huge and they cannot afford it. So, I mean, what we are doing is that we are trying to find a company who can install the solar PVs on their site, and then the bill, they will charge the actual bill from that development authority. And that's how there is going to be some kind of financial model. The same is going to happen with the other things, the other provisions that we provided, because the savings are actual in kilowatt hours. We have, kind of followed throughout the year, and we saw that the savings are substantial. So, I mean, we can get a good financing and ESCO companies who can work with these municipalities and actually get back the profit, that a portion of the profit that the development authorities or the municipalities are getting from those projects.
Thank you. I think this should be rolled out, because these success stories should not be
Yes.
just self. It has to be rolled out so that other municipalities would. But again, the funding issue. So rather than going to the capex model, so you go to opex, and you don't have to spend money upfront,
Exactly.
or the resources and human, capital. So I think that may be my thought. So last, Ms. Munir, I think you have a big, you said that Bangladesh is like the land of potential, thousands, millions of car. Electric vehicle, you said only 16 charging stations so far and 6 are under development. I think that's too less. We need to work with SEDA, I think, so that what Rina was presenting, like the batteries in the car could be already a battery storage, energy storage. So all multiple electric vehicle owner are the battery store. They would act as a store. So a consolidator should be there who would sign a contract with each vehicle owner and contribute to the or consolidate as a battery as a battery, like I don't know what exactly would be the name, so that that consolidator or the company would have a long-term contract with BPDB, say, or anyone, Disco, so that it will provide the battery storage energy to manage the peak time, so that you could avoid the network congestion, also avoid your rental gas generators. I think we need to work out. So I don't. This is not my question, but I just thought, because there's so much of vehicles, and that needs to be electrified in the end, and that electric battery should be used as a storage, BESS. I think that going forward would be the way. And there is like a lot of evidence of having a lot of population and rich people in Bangladesh now. We are growing at 6%, 7%. So this, I think, we need to look at the India side, how they are developing, and we need to copy as well, I think.
To monetize this, it is very important that we have the ancillary market also develop. So once these battery storage act and send it to the grid, they should not sell at a base price. It
Exactly.
should extract the premium.
It should be Uberized, like Uber. Everyone will be registered, and they will provide their battery to supply for a certain time, so that you'll have a consolidated battery storage, and you can provide to the system.
One comment. It is very difficult to dispose of the end of the lifetime of batteries. So battery management is a problem, big problem for Bangladesh. So we are thinking about how to manage it or dispose it, and it is very urgent to take any action.
The technology is coming.
And I mentioned in my keynote speech that 4 million battery-driven vehicle is running. And this 4 million vehicle needs 25 megawatt electricity per day, they uses. So you easily understand.
Yeah, that is true.
How
Mr.
big is
Islam,
the
you have something.
demand.
Thank you.
If I may, actually,
because electricity is a very precious resource. Energy is very precious resource for all.
Thank you. I think I noted. Thank you.
Just to add here, actually, since we are running the distribution companies, what we need to do is that there are two issues, as we have experienced with India. First is the tariff issue, so that those who are EV charging stations and the users, they would be interested in the during day hours to recharge the batteries. This is one thing, so that they won't actually overload our system during the night time, number one. Number two is that there is one more system that we need to introduce, is the net metering system, so that they can buy directional meters, so that they can really recharge their what do you call the extras battery charges to the system, number two. And as we have calculated, as she was telling, the tariff is basically 9 taka versus 7 taka. So when they provide charges, actually, they will save, in case of use of renewable energy, they actually save 2 taka. And in case of giving it to the bulk rates, there is also, government is concerned to increase the bulk rates so that they will make money out of it. So as soon as there is a business case, the whole ecosystem will change.
Thank you. Very good idea. So I think, sorry, we are running out of time. I see. So thank you so much. Yeah, and now we will wrap up this session. And we have, of course, We really thank our panelists, speaker for their contribution, and also the audience for to being with us. And for your information, all the presentation that we had would be posted on ACEF website, maybe 1 or 2 days later. So you can have access. And for any question, please feel free to reach out to us, and we can reconnect to our panelist speaker. And again, thank you very much. And I think we have a lunch on the EDR on the first floor or also in the courtyard. So either of the two you could choose. And let's regroup again, maybe in the next session at 2 o'clock. Thank you so much. Thank you. Photo.